Okay, we're going to try a slightly more challenging logarithm. You can see that we have a plus sign in between these two logarithms. And so I need to somehow combine this one over here with this one over here, because I can't try and do the thing where we put each to a power of 2 yet. I can't do that because there's the plus sign in between them. I need to combine them first. But we need to remember that there's nice properties of logarithms that say that if you have a plus sign in between two logarithms, if I have that sign in between, then that means times in the middle. So I can combine them with the times. So let's do that. So we're going to make this one logarithm. So it'll be log base 2. And then I'm simply going to multiply x plus 1 and x minus 1, which becomes x squared minus 1. Now, it's not too bad. I simply put each side of this equation as an exponent to the same base of 2. That cancels out. And that gives me x squared minus 1 is equal to, this is 2 to the third power. 2 times 2 times 2 is 8. Okay, from here I've got an exponent of 2, so this is a polynomial. Let's go ahead and set this equal to 0 and see if we can't factor. I could also use square roots, but factoring is kind of fun, so we'll do that. This is a difference of 2 squares. It becomes x minus 3, x plus 3. Okay, from there I think you can see that x equals 3 is definitely one of the values, and x equals negative 3. But we need to make sure that none of these values cause us to get a negative or 0 inside a logarithm in the original problem. So I got to go all the way back up to here and make sure that it does not give me something bad. Well, if I put in a negative 3 for this x here, and if I say negative 3 plus 1, well, that's a negative 2. I can't have a negative in a logarithm. So that's not allowed. I can't do that. That's extraneous. But if I use the positive 3, I get the log base 2 of 4 plus the log base 2 of 2, and that indeed will equal 3. So we have one solution here, 3.